Hello, everybody. In this video, we have Sri with us. So before we start, Sri, do you want to introduce yourself a little bit, give us some of your background, what you are doing on Databricks, and then we'll go into the project for today.
Cool. My name is Sri. I'm a lead SA at Databricks. I work in the retail region, and my background when I first started Databricks was more focused around like automation, platform, cloud, and then slowly Databricks started investing more in the Gen AI space. And that's kind of where in the last few months or so, I've been spending a lot of time working on projects around deploying foundation models, as well as things like agent frameworks, getting things to deploy, creating like a really good dev loop within the Databricks platform has been my focus in the last few months or so.
Which takes us very nicely to the project we're discussing today called MLflow Extensions. So what is it exactly, and what are the use cases we can use it for?
Yeah, it's probably a misnomer to call it MLflow Extensions. Eventually, we'll probably
Yeah.
end up changing the name. It's not really trying to extend MLflow per se, but to make the dev loop of deploying foundation models easier in Databricks. With the path of being able to support that, it comes with other nice to have copy and paste type functionality like testing model deployments, things like that locally on a Databricks cluster versus having to wait for a full deployment container build. Like you might not want to do that when you're just iterating. So this kind of has functionality to do that. But at a very high level, the focus has been on deploying vision language models. Those are things that are not overlapping with what Databricks is already doing for you out of the box with provision throughput. We support any models that support text-based, text input, text output. But vision language models are interesting because they let you do text and image input and get text output. So traditionally, you might have used things like object detection, etc. But the nice thing is you can just take a pre-trained model, do no training from scratch, no labeling. You can give it an image and ask questions about it. And that's very powerful, at least in the retail space where I'm focused on. So that's the main focus of this project, is to deploy those types of models very easily in Databricks on all three clouds with a varying degrees of support based on what functionality exists in that cloud. The bare minimum is you need GPUs. That's the minimum.
Okay, so it's more about then, when you say visual models, you mean object detection models, so not kind of like visual to text models or text to image models.
So it's not object detection models.
Mm.
That's typically what you might have seen in the past is you
Mm.
might have, let's say you have a bunch of apparel and you have photos of apparel.
Yeah.
You might train a object detection model to say, oh, this is a pair of jeans or this is a pair of like this type of clothing or apparel. And you'll need a lot of labeled data and training sets. There might be some pre-trained ones out of the box where you don't have to do any training, you just use it out of the box.
Yeah.
But the nice thing is these models, like the Quen vision model or the new Llama 3.2 vision models, have been pre-trained with a lot of images and text. So you can ask it very basic questions like, is this a ripped pair of jeans? Or is like, what type of design is this? Is this denim? Like, what's the color? And these are questions that you, in the past, you might have to train model. You might need all the data sets to be able to do this. And this would be like a 3-month, 4-month project. Now you just deploy this in production in a couple of weeks, and then you have an API that you can then hit and send to images and ask questions about the images to a pretty good degree of accuracy.
Okay, amazing. So then the project as of now, it supports any of these models that you mentioned, but also the regular text models, text to text.
Yep,
Yeah?
it can do text to text as well. Text to text, Llama has been, from an open source standpoint, has been leading the market, and Databricks offers the provision throughput. So I haven't put too much effort in text to text,
Okay.
but there is a specific place in text to text where I am seeing maybe some interest in, which is like quantized text to text models. If you want smaller versions of the Llama model to fit on smaller hardware, just do some development or testing. That's another area where um, I could see support for it.
Okay, amazing. And then there are two ways of deployment that you mentioned. One was through the Databricks cluster and then through the model serving. So can you deep dive a little bit in both of those and see when we should use which?
Yeah, so you should use model serving if it's available in your region. The way that, just kind of like maybe step back a bit and explain,
Mhm.
right? Databricks, the way we run model serving is it's run in serverless capacity. And when you think about cloud vendors like AWS, Azure, GCP, they'll have data centers across all the regions. And Databricks pre-acquires VMs and runs them in a pool and offers you serving. What's really challenging to do in the case of foundation models is it's not traditional commodity hardware. You need high-end GPUs, data center GPUs to run this. And that comes with a large capital upfront cost. So we need a large user base in that region that is wanting to deploy this specific model. So when we roll out regions, not every region is going to have, they might have model serving, but they might not have GPU pools available.
Yeah.
So to allow any customer of Databricks to run this on any region, um, we offer the flexibility to switch between model serving and clusters. The recommendation is to use model serving with GPUs if you have that in that region. And if you don't, then the fallback would be to run this on a cluster and expose that through an API.
Makes sense. Okay. And then are you gonna deep dive into how it works in both cases later in the demo?
Yeah, I can deep dive into that right now. There
Okay, amazing.
is a architecture diagram that kind of walks through this. So the unique thing to talk about this is typically the way that models are deployed in Databricks right now is you deploy things using MLflow. It's a framework that lets you manage and version models and artifacts, but it runs off of like vanilla Python functions, and it lets you have inputs and process inputs. The challenging thing about running an LLM is it uses up a lot of resources. So there are optimized servers that do this as a job. And MLflow serving is not like the default serving infrastructure. When we talk about Databricks serving, provision throughput is an entirely different serving architecture than the classic serving, which is using the standard MLflow serving architecture.
Mm.
And those are not going to be using these optimized serving frameworks. There are a couple of them to name are things like Vllm, sglang, Rayserve, or TensorRT LLM. So those are like optimized serving frameworks for serving up LLMs. There are some things like Llama, which is like for local serving, but the goal is I need to fit these serving frameworks into the classic model serving with Python functions. So
Mm.
how do you do that? And so one of the things you might say is like, let's just run the server and see what happens. Um, the way that it works is in MLflow, there's just two methods that it uses in Python. One is the load context, and the other one is the predict method. Predict method takes inputs and gives you outputs. That's what you typically want to do in any model. If you have a classification model, you give it some input, and then it gives you the classification label as an output. In a text-to-text LLM scenario, you want to provide it a question, a prompt, and you get text as the output. And typically, in a containerized solution, you might run multiple instances of the model. But in a given container, you don't want to run 4 servers in that container. Typically, you might run 4 workers to handle requests, but you don't want to run 4 servers of Vllm or TensorRT. You just want one server that can handle requests from 4 different workers. So that's the architecture. But the way it works is when the model loads, it typically has n number of workers. All of them try to write a file in the file system, and the first one that succeeds is basically the elected as a leader. That
Okay.
is the worker that starts the server. Everyone else just waits to see if the server is ready. All of these server frameworks have a health check endpoint, so you just check to see if it's healthy. And that's how it works in model serving. So when the model gets deployed, let's just say you have 4 workers, one of them gets elected, that one spawns the worker, and then the other 3 workers just keep hitting the health check endpoint to see if it's ready. And then after a while, it'll time out, and then the serving fails because, I mean, things can crash, the model might be corrupt, or you just might not have the right configurations. Um, in the cluster scenario, it's a little bit easier. You have control of how many process, so you just run one process and you're good to go. But in model serving, you don't have control of how many processes or how many instances of the container that Databricks decides to launch. So that's why this workaround needed to be built to support this.
Amazing. Okay, cool. And then before you mentioned around that the when you created this tool, should we call it this library, it was mainly focused on testing. So, as we start developing applications and we want to create these PyFuncs and test it locally before we model serve them, it takes us usually a lot of time and it's a little bit painful to go through the process. So how does this help us test locally before we even send it to the model serving?
So there are some, so I think what you can do is you can easily test your scikit-learn model, your classification model. That's like very easy to test. You give it inputs, you give it outputs. What's really hard to test is MLflow abstracts like this weird data structure of like data frame inputs or tensors, and it usually fails during the deployment process. This is going to get better natively in MLflow. So some of this work might disappear and we just use native MLflow capabilities. But this example right here just shows you how to create a sample local test server that you can run on any Databricks cluster. And you give it a registered model, you give it a host and token. Again, this is specific to Databricks. And then you can then ask it, hey, do you want to use a local environment? Do you want to create an entire installation of Python from scratch and do this? So this gives you this integration testing directly in a notebook without having to wait for a container to build and then realize that you have an error, you go make a code change. Like this makes a dev loop directly in the notebook.
Yes, that's actually so helpful because it takes, sometimes you have to iterate a lot of times, right? And to kick off endpoints all the time and waiting for it to fail to see what failed, that's amazing actually.
Now imagine you're trying to build the previous architecture and how many iterations that would have taken to like get it to work. So this was actually extremely helpful to just spin up a GPU cluster and just test locally.
Yeah, amazing. So at the moment, which models are you supporting through this library? And then I guess, do you have a way to choose the best cluster, or we have to deal on understand, how big is the model, what kind of cluster we have to choose for serving this model?
Cool, that's a really good question. So let's start with the first one, which is model support. Let me make this horizontal, supported models. So there is so there's actually one thing that there's actually another company called Fixie AI. There's another category of models. There's just one of them right now. It's open source. It's called an audio plus text to text model, where you can also give it just a traditional audio recording, 1 minute, couple of minutes, and you can ask it questions about the audio. Typically in the past, you might have to do transcriptions using something like Whisper and then pass it to the model. This kind of takes care of that. So there's three classifications. So in the text models, there's quite a few of them. Again, these are models that you typically won't see in Databricks, so none of the Llama models will be in here. You should just use the Databricks out of the box ones. But these are some of the ones that are somewhat popular. There is one Llama model is just to test this framework called sglang, but I would recommend you to use the Databricks one. From a vision standpoint, the Lava models are there. That's a family of them. The One Vision is the latest one. When we say vision models, it's usually some sort of vision encoder model plus some large text model. So you'll always see like Lava, Mistral. It's because they're using the Mistral for the text model. Then there's a Phi, there's a Quen, and the Pixtral. And one of the interesting things you'll see is like, you're gonna be like, Shri, like, why is there two copies of Pixtral? So every one of these models has something called a context length, and you can provide it. And every image takes up n number of tokens. So an image can take up 1,000 tokens. It depends on how the model architecture is designed. And you might want to deploy a smaller model because you have a very small, simple task and you don't want really large hardware. These serving frameworks like Vllm let you control the context length that you want when you deploy the model. So even though the model like Llama 3 is 128K context length, you can just say, I want an 8K context length model because I don't plan on using it and want to run on smaller hardware. So you have the flexibility of choosing that.
Okay, so are you then referring to, for example, when you send a request to the model, if it has, let's say now for the simplicity, let's say it has 100 tokens context length, and you just always send 10 instead of just fixing the other values and always passing the biggest context length, then you just say, okay, I always gonna pass smaller context length, so I don't need the rest of the context. So just
it can save you a lot of GPU memory when
yes,
you deploy these models. So you can just run them on smaller hardware. So typically the two things is like the batch size, how many concurrent request batches can it process, and then what is the model length. And both of them determine how much GPU memory needs to be pre-allocated to these serving frameworks. They typically all work in somewhat of a similar fashion. And those are the two main knobs, especially in Vllm, to reduce that.
Okay, great. And then how we connect the dots from that to the GPU machine you need to choose for each model?
So the nice thing is the way that this library is designed is it's kind of like recipes. You can always choose to follow the recipe to the T and use it for what it makes, or you can tweak it and modify it to tailor it to your tastes. So these recipes are in the code. If I go to the repo, in the code itself, there will be examples of the recipes, and you can kind of see like what the settings are. And you can literally copy and paste these settings and run these themselves rather than using the pre-built ones.
Yeah.
But my recommendation is just to start with the recipes, see if that works. They've already been tested. There's just a giant notebook that runs end to end, just spins up a GPU cluster and just runs through every single recipe just to make sure, can I run on this compute size? And then they're also mapped to the Databricks endpoints that we offer automatically as well. So they'll automatically be deployed to that specific endpoint for you. But if you choose to go out of the box and you say like, hey, I want a completely different recipe or settings, then you can go back into the code and copy and paste it.
So these recipes are only relevant to the compute or also to the Vllm, for example, configuration you can do?
Yes, so they also have the Vllm configurations
Okay, nice.
predefined as well. So like there's a very common data extraction task. Like I have a text or I have an image, give me JSON as an output. And there are specific techniques like guided decoding that's available. Like if you have used OpenAI, they have something called like response type, and you can pick like a JSON object as a response type. Databricks has that for the Llama models as well. Those things are already pre-configured for you in the code right here. So like these are all of the engine configurations for Vllm. So it's like a little bit more obvious in the vision language models because there's so many different settings that you need. But these are all the Vllm settings that are predefined for you in the recipe, so you don't have to think about them.
Amazing. And then how do we handle authentication in this kind of application? Is it again through model serving, right? There is nothing different.
Yeah, if you use
Or
model
for
serving, it'll be through the standard. Like if you're using route optimized endpoints, you use OAuth. If you're using vanilla model serving, you just use the PAT tokens or OAuth if you want to. If you're using a cluster, it's not like production ready. We use something called the driver proxy API. If you look at Databricks LangChain examples or the old Gen AI repos, we have examples of this. It's mainly meant for testing, but if you have nothing else in that region, then that's going to be your best way to deploy a foundation model. That's through PAT tokens. So traditional Databricks auth, you're not doing anything special.
Amazing. Okay, good. And last question on my side. How are we gonna upload images to this, given that it's not that easy, for example, through the playground or the current offerings we have? How are we gonna test it? Yeah.
So there are desktop clients like Chatbox that you can use. Let me share my window really quick, and hopefully that doesn't mess with your flow, but I'm just going to share my screen. So you can use tools like Chatbox, and you can upload images here. Again, the playground doesn't have this capability. So you'll have to use other clients. Again, this is only if you need a UI driven. Most of the times it's just code.
Okay, so then you use it usually through AI queries, or you serve it on the model serving, and then you are hitting it through AI query.
Yeah, and the really interesting thing is, if you go through the deployment on a cluster, which I'll show you, it deploys as a Databricks job. You can actually take the output of this job, so it gives you a URL when the job runs. This one is using Apache Ray, so it's a little bit lengthy, but it gives you a URL, and you can actually register that URL as a model serving and as an OpenAI endpoint. So you can actually integrate it to our gateway, and you just access it like it's just you won't even realize that it's an actual model running on a cluster. You'll, like any end user that wants to use this foundation model, will just use this out of the gateway. They should not be hitting the cluster directly. And then you can apply rate limits, etc. All of the things that you can do on the gateway through this.
Oh, that's really cool. That you can incorporate it through the gateway, and then no one knows what's happening behind the scenes.
Yeah, it could be you can swap out the model as well. Every model is considered default. So when you're accessing it, it's just called default. So users don't really know what's running under the hood.
Okay, amazing. Cool, thanks. Really cool.
Awesome. I think that links to like the other question we wanted to ask in terms of logging. What logs exactly are available, to the user? What kind of access do they have? Can you expand on this?
So it's still being worked on. So there is a custom logger that's built into this. So if you look over here, there's like the custom debug logs. Let me go to the job. I think it's easier to show you from one of the jobs here. Let me see. This is not a good one. This one. Yeah. So if you look over here, there's tons of logs here. MLflow logs, model serving logs don't persist in the long run. So we have a custom logger, and there is a file rotation mechanism for you to log all of this to volumes. And that's still being worked on by a colleague, Nate. So we have an initial MVP. It's just more on testing and ensuring that it can log to volumes. But that would be the goal. It doesn't matter where you run this. It should push all the logs to volumes. And then once it's in volumes, it's just files. So you can use the rest of the Databricks product suite to query that.
Awesome. And another question is, how do we ensure full utilization of the GPU?
Another really important question, right? You're paying, the way in Databricks you purchase for this, you're paying for the hardware. And how do I make sure I'm fully using the hardware?
Because usually when that is taken away from the user, right? So they don't really have a lot of control on how much CPU they are utilizing in a model serving endpoint, for example.
Yeah, it's completely abstracted. Yeah. All you know is there is a GPU. That's all you know.
Yeah.
So the way that the serving framework, specifically Vllm, is it splits up. There's something called the KV cache. It's basically used during the inference process when it's generating the next set of tokens, and it pre-allocates a large portion of the GPU. And you can configure that. And the way that we're defaulting everything to is like 98% of the GPU is allocated for Vllm to be able to use. So there is an option in Vllm to pre-allocate everything for that process. So there's nothing idle. And the next thing that you can do is things like AI query, or things like using multi-threading to ensure that you are saturating the GPU. That word comes up a lot in this space. It's saturation. You want to make sure you're hitting it with more requests than it can handle. All of these serving frameworks have a queuing mechanism. They will queue it up, and in the logs you'll see, hey, I am queued up. So if, let's say your arbitrary number 100, it'll say like 64 requests in the queue, which means that 36 are still are like being processed concurrently, and they can't process anymore because it's going to run out of it doesn't have enough memory. And the scheduling, all of these serving frameworks have their own scheduler. They know like how much memory is available, and they will try their best to allocate as much of the GPU as possible.
Awesome. So it just in simple words, I guess, Vllm is a tool that makes like running LLMs just faster and more memory efficient for people who don't know what that is. Sorry, Maria, what were you saying?
Exactly.
Yeah, I was curious on the AI query then, if you use AI query with this approach. So AI query has a process behind the scenes that helps you kind of make sure that you're overutilizing the cluster in a sense so that you don't have idle compute.
That's what I want to test. That's one of the things that I was talking
Okay.
to colleague Puneet of mine on this is like, in theory, AI query with their revamp that they did should work with this because this is, to AI query, this is an open AI endpoint.
Yes.
Yeah.
Okay, cool.
Awesome. And how does Ray fit into this setup? So just for people who don't know, Ray, it's a distributed computing framework that's designed to really simplify like scaling, parallelizing, Python apps across like cores across machines. So how does Ray fit into this?
So there's two things. So if you're deploying this on traditional model serving that we recommend you to, like as a default, if you have that available in your region, you don't need Ray. You just run this as a process. Vllm has two modes of operating, one with Ray and one with multiprocessing, which is just a Python traditional parallel processing library. That's the default. But if you now think about it, where you're deploying this on a cluster, you're like, hey, Databricks model servings auto scales. Like, how do I do this on a cluster? And the way that Databricks is designed on a traditional cluster is clusters scale using Spark. And this is not going to use Spark because this has nothing to do with data processing. It's just running a process to serve up an LLM. So auto scaling is purely for clusters is determined by Spark. But we need auto scaling, otherwise we will only be able to process n number of requests on a cluster. So where Ray fits in is we actually use Ray placement groups to place model workers across the Ray cluster. And Databricks has this nice feature called Ray on Spark. So there's two features actually. There's Spark on Ray and Ray on Spark. We offer Ray on Spark, which means Ray is running as a process within a Spark task. And now that you have a Spark task, and if something requests more tasks, then the Databricks cluster will auto scale. So what we do is we deploy the Vllm process in one of the Ray placement groups, and we let the autoscaler in Ray tell Spark, hey, I need more nodes, and then it spins up more GPU nodes. I did not build any of that part. Puneet, my colleague, has spent a phenomenal amount of time exploring Ray, and I gave him like little hints and guides on the Vllm documentation on what works, what doesn't work, and some of the issues in open source Ray that we saw that needed to get fixed. And eventually he pulled through and quickly got that working. And one of the examples was that I showed you was the job that's running on Ray. So there's actually three modes. We call them easy deploy because they are just recipes that you can easily deploy. Vanilla easy deploy deploys to model serving. Easy deploy light deploys to a single node VM. It's just for testing, but that's all it does. And then easy deploy Ray deploys this on a Ray job cluster, which is what this is not it. This is it. So it's deploying on what's called Ray Serve. Ray Serve is not as important. It's just a feature in Ray that lets you expose a local endpoint. But there's very little Ray Serve code that we're writing. It's mostly just running a Vllm process.
Got it. Also wanted to ask about how it integrates with the AI Gateway, but I think that question was already addressed. So last question on my side, are you looking for contributors to work on this awesome project?
Yeah, there's actually quite a different set of areas that we can definitely use contributors. I think the Vllm space is still a good area, at least because people that are focused or really want to be able to use these in Databricks. I think vision language models are probably the most valuable that I see that this project can support. Other things that we're also looking at is other serving frameworks. There's another one called Infinity. It's for optimized embedding model serving, and you can run that on L4s or smaller GPU architectures. But the main area of contribution is definitely around model support. It's mostly model support and testing. Those models will run on the GPU hardware and needs to be tested on all three clouds. There's some degree of like guarantee that we want to be able to use to provide to end users of this is if it works on one, it should work on the other three. That's why all the abstractions is around like GPU memory, because you might not get the same types of GPUs on all three clouds. Like just to give you an example, if you think about an A100, there's actually two variations of an A100. You can have 40 gigs of GPU memory or 80 gigs. And you can't just say A100, like you can run this model. It's like 40 gigs of A100, you can run this model. So there's those things. And then certain optimizations only work on certain GPU categories. So like the Ampere family of GPUs can only run certain things. So there's quite a lot of complexity and learning space. But if you want to just get started, the easiest one is just to pick up a new model like Llama 3 and copy a recipe and see if it works. And testing to see if it works is like a few lines of Python code. It's pretty well documented on how to get started. So it tells you how to install in a notebook, and then you can literally just run these few lines of code, and then you're done. That's it. The rest of it is just like calling.
Easy, very straightforward. That's really easy.
So you can copy the code where this recipe is and just add a new model name and see if it works. If it works, you just raise a pull request. It might not be that easy to get the pull request approved because then we need to test it on all three clouds and confirm that same model will work. But we got it to a point where it's easy for us to add new things. Now it's just like sitting down and testing. So downloading the model from Hugging Face is probably the biggest dev loop bottleneck. Is some of these models like the Llama 3 90B is like takes a good 15, 20 minutes to download. So it's not that fun.
Amazing. I know you've been showing, parts of the solution. Should we do a demo, quick demo?
Sure. So I didn't want to really demo deploying because this is actually it. This is the code for deploying. And then once you actually run this line of code, like this myQuent model, you actually get this as the output. And this is the job that's running. And the way it's designed is OpenAI, just to be frank, set the standard for what a server like request response should look like. Everyone tries to emulate the OpenAI client. If people have already started building apps in OpenAI, will claim that, or people will build their serving endpoint such that it's compatible with their SDK. That's the same thing that Vllm does. SGLang, the other serving framework, and even Ray, it's OpenAI compatible. So at the end, you'll get a URL that looks like this. And basically, you can run that's the base API path. So in OpenAI, if you don't have the public OpenAI model, you can provide a base path and then an API key. The API key in this case is just a Databricks standard path token. And this is the base path of the API. And then everything else is you just use the OpenAI SDK. So let me show you what that would look like. So you pip install the library. Again, in this case, I'm actually not using the library. So you can ignore this. This was from an older demo. You just need to install the OpenAI client. That's the pip install. And the beauty of this is it just works on serverless. So you don't need ML runtime. You don't need anything special. You may need MLflow because it helps you get a token very easily. But if you want to hard code your token or use Databricks secrets, you don't need this either. So you have the OpenAI client. The base URL is just the endpoint URL that's provided there, and the token is the PAT token. I'm using a notebook provided token, but this could be a PAT token, this could be an OAuth token. It doesn't really matter. And if you register this in the AI gateway, you can use Chat Databricks, and you can use more of the native Databricks stuff. I designed this assuming that most people that are using vision models, the one that people you typically use is GPT-4 Vision. And if you use GPT-4 Vision, it's very easy to switch to an open source vision model. That's why I picked the OpenAI client. So the other area where I've been spending a lot of time on is data extraction. So there is a large portion of the time that I spent is on how do I get JSON output out of images? So a lot of times you might want not just text, but you want very structured output. And Databricks is typically seen as a data ETL ingestion platform. And a lot of times you'll have unstructured data like images and text, and you just want structured output. You don't necessarily care about text. So these frameworks have something what's called guided decoding. It limits, so in an LLM, what it does is it's a really smart auto-completion. It can complete the next token and keep going. Guided decoding just limits the space in which it can pick its tokens from. So it needs to look like JSON. It's going to force it to look like JSON. So in Python, there's a library called Pydantic. It's a very standard thing that you might have in other languages. It lets you define a class, it lets you define the data types, and just validates that those data types are there. What this gets turned into is a JSON schema. And from the JSON schema, it gets turned into this giant, ugly-looking regex state machine. And then it tries to complete that regular expression. And it forces the model to decode or generate tokens that will complete this. So not only did I want it to ask it a question to compare the two images, I wanted to get a very structured output and guarantee that the output is going to be the structure. So there's two approaches. You can do and control the response during decoding, or you can do prompt engineering and try your best to get the JSON output and then pass that into Pydantic and validate the JSON, and then retry telling it, oh, this part failed. There's trade-offs. There's no free lunch here. If you do guided decoding, it's slower. You need optimizations to make sure that it follows that. Whereas if you just get it to generate giant globs of JSON, it can decode much larger chunks of text. And then essentially you just validate after, and then you generate more. This guarantees some degree of structure, but it's also slower. So there's that trade-off there. But if you're deploying as an API, it's a reasonable response time. And this is what the output would look like. So this is my model. These are just two images that I took of a pair of jeans. One is just a standard pair of jeans, and then the other one is like a ripped pair of jeans. And I'm asking it, like, give me details, give me the colors, give me whether it's ripped or true or false. And the data types are going to tell it what JSON data schema should look like. So that's the other nice thing is about more modern VLMs is they allow what's called interleaving images. Typically, you might not want to ask questions about one image. There's quite a lot of use cases, like let's say an insurance use case. If you have two images of a good Toyota, like Toyota, and a damaged Toyota, you want to show it what good looks like, and then show it what bad looks like, and then identify like what parts of the image look damaged. So there are different things you can do. Like here, I'm just showing an example of like comparing two pairs of jeans, but you can always compare it to like two ads. And if you want to do like typically, if you're comparing two advertisements and you have like a panel, you can use the LLM to simulate a panel and give it different personalities and see how it would perceive the two images. So there's quite a few things that you can do because it's still backed by a text model. And if the text model is large enough and is pretty good in its ability to like role play, you can prompt it to behave like a certain personality and evaluate images as well.
So Sri, could we just pass it through the Databricks structured output? So is it very similar? Is it a different thing?
So Databricks structured output only works for the foundation models that we offer.
Okay.
So you wouldn't be able to do. You can't take a custom model and use the Databricks structured output if that makes sense. So we do support JSON response output. I think it's a public preview. But that only works for the Llama foundation models. This is just doing it for other types of models.
Okay, sounds good. Amazing.
This was the high-level demo. This is more of a picks and shovels project. It doesn't have a full-fledged end-user application. It will give you like the baselines to introduce a new type of functionality to Databricks. So most of the demos will be something similar to this. Just to show you some of the other notebooks is, so this is my other favorite one. There's a model called Ultravox, and this is with audio data, and it's very similar. You deploy this is using easy deploy. It's slightly different. You do register this to MLflow. That's the nuanced thing about the MLflow deployment is you do, or the model serving deployment, you do need to register MLflow. It needs to be in UC. So this does have a little bit more steps, but it's still a few lines of code. And then you can send it audio data and ask it about the audio data. So this is another cool aspect of, typically if you're doing call center or call center analysis, you do transcripts. I think you should still do that process, but this gives you the ability to expose an API where someone can just upload an audio image and ask questions, where in the call transcript use case, it's like more ETL pipeline process. So if you're deploying a web service or service that can do this, this is a very convenient model to be able to do that.
Very cool. So you mean you don't really have to transcribe first? You just send
it can
the
do the transcription. So,
Okay.
so the way the vision models are done is they'll take a pure like clip model or siglip model, and they will create encode an image to tokens, and then try to train the model in the same embedding space. What this is doing is actually just uses Whisper to encode audio data and tries to train that along with a text model. The Ultravox model is using the Llama family of models with that. So it's able to understand the underlying meaning of an audio data, and you're able to ask it questions. You can also ask it to transcribe. I've seen pretty decent transcriptions out of it as well. But you just use traditional Whisper at that point if you just want transcriptions.
Exactly. Yeah. Okay.
It skips that step entirely.
Amazing. Is there anything else you think we should mention?
No, I'm trying to keep the project scope as small as large as it might have seemed. It's very focused on vision language models, and if there are any new cooler audio language models. The only other thing that we're adding is for certain embedding models. Right now in Databricks, you can get the BGE and the GT large. The challenge is that's great for the States or English-speaking countries, but when you are going into the multilingual space, you do need, there are other better models depending on the language, and being able to support some of those are things that another area where I'm looking at.
Cool.
Amazing.
Good luck.